Okay, today I'm taking one problem. It's a men's problem, and it was asked in JEE Main 2014. Okay, it was asked in JEE Main 2014. Mhm. Problem says a particle is released on a vertical, smooth, semicircular track from a point X. This is your X. A particle is released. Okay, particle is released. So particle is here. It is released without any velocity. Just it is released, so that if you see here from a point X, so that OX makes an angle theta. So this angle is theta. OX with vertical, it is making an angle theta. Okay, the normal reaction of the track on the particle vanishes at point Y. So at this point, this is your point Y, where normal reaction vanishes. Means there is no normal reaction at this point. What does it mean? Normal reaction is not there at this point, means there is no contact. There is no contact between this particle and the surface. It just it is leaving the surface. Whenever two surface is not in contact, then there won't be any normal reaction. Okay, there should be contact. Two surface should press each other, so that there will be normal reaction. But when particle is released from this point X, as it reaches Y, according to the question, the normal reaction vanishes. Means at point Y, normal reaction is 0, according to the question. So where angle OI is making an angle phi with the horizontal. You can see. Now you need to find the relation. Okay, these are the option. Four options are given in mains exam. Four option will be given. You all know that. So out of these four option C, there will be 20 question in mains physics exam. In mains physics exam, there will be 20 questions for multiple choice, and there will be four options, out of which one will be correct. And remaining 10 questions. Remaining 10 question will be numerical based. There won't be any option. From there, out of 10 questions, you have to do 5 questions. So altogether, there will be 30 questions in mains physics exam, out of which you have to do 25 problems. Means 20 compulsory, and remaining 5, out of 10 problems you have to solve 5 problems, and those 10 problems are numerical, out of which 5 you need to do. And there won't be any option for those 10, out of which 5 you need to solve. So for 20 questions, first 20 questions, there will be 4 options. So this belongs to that first set of 20 questions, and out of this 4 question, 4 option, only one option is correct. Okay, this was asked in mains 2014 exam. Okay, in 2014. Now let us solve this question. Now see, when particle reaches Y at this point, same particle. Okay, I have shown it with this red dot. This particle, as it reaches Y, there won't be normal reaction. Means it is leaving the surface. Now let us see. Now we need to find the relation between sine and cos, because option you can see. Now see here, for x let us do it first. For x let us do it first. Now if you see this height, you can find. Let me write this as x dash. So if you use simple trigonometry, you will find. Let us see this circular track, semicircular track. This r with the radius. Okay, r with the radius. R with the radius. Now ox dash, which is the height. Ox dash. I'll do it here. Ox dash, that will be equal to r cos theta. Simple trigonometry. Okay, r cos theta. Now at x at this height, if you see potential energy. Okay, potential energy, it will be, if m is the mass of that particle, m is the mass of the particle. Okay, mg uh, r cos theta, mg r cos theta. Now for y, similarly, let us see for y. For y, see, as it is falling downward, its potential energy is decreasing, and kinetic energy will be increasing. So at this point y, there will be both potential as well as kinetic energy. We are taking this point O as reference. Okay, for potential energy, for calculation of potential energy, we are taking this point O as reference. Now let me find uh, this height. We need to find this height. This height will be uh, okay, I'll write this as o dash. Okay, So O dash y will be how much? uh, O dash y, which is the height, O dash y is equal to, that is your r radius, so r sine phi, r sine phi. So potential energy will be, potential energy, this is at y, okay, at y potential energy is how much? At y potential energy is equal to mg r sine phi. Now we'll use energy conservation, so for that we need to find kinetic energy as well, okay. At x, since velocity is 0 here, at x velocity is 0, kinetic energy was 0 because it was released here, just release, initially velocity was 0. Now as it reaches point y, as it reaches point y, then there will be both kinetic as well as potential energy, okay. Now since normal is 0 here, at this point there won't be any normal reaction. This if I show this normal value is 0, means it leaves the surface, okay, at this point y. Now if you uh, see here, if mg weight will be acting vertically downward. Now if you draw projection here, if you draw projection here, if you draw projection, uh, this value how much you will get? This is phi, so this angle will be your 90 minus phi. This angle will be 90 minus phi. So I'll draw that triangle here, okay. Maybe it's difficult for you to visualize that thing. Now see, since this angle is phi, so this will be 90 minus phi. So from this is your mg, from here you are drawing, see this angle is your 90 minus phi, from here you are drawing projection, that is mg, this is your mg, from here you are drawing perpendicular, okay. So what will be the component of mg along this, along towards the center, means radial, radial component of mg, radial component of mg will be, now if you see radial component of mg, radial component of mg, how much you will get? It will be, say, mg cos 90 minus phi. So mg cos 90 minus phi, this side you will get mg cos 90 minus phi, mg cos 90 minus phi, 90 minus phi, okay, mg cos 90 minus phi towards the center of this semicircular track. Now see, net force towards the center of a circular path is centripetal force, okay. So net force, let us see, since normal is 0, so net force. Now net force, keep in mind, okay, net force, net force towards the center, towards the center is always center is always, center of a circular path you can say, is always center is centripetal force, and which is given by mv square by r, centripetal force mv square by r. This means what is the net force? See, mg cos 90 minus phi, towards the center it is acting, and normal is acting in this that direction, and normal value is 0. So you can put 0 for normal value. So see here, mg cos 90 minus phi is mg sin phi, mg sin phi, normal value is 0, is equal to mv square by r. So from here you can see, from here you can see mg sin phi, mg sin phi, mg sin phi is equal to, see, mg sin phi is equal to mv square by r, mv square by r. So m you can cancel, so you can see b square is equal to rg sin phi. So this b square value you can use in order to calculate kinetic energy, because if you see here, you see here, already we have calculated potential energy at this point y. Now we'll find kinetic energy as well, because b square we have found, so half mb square we can do, and we can use energy conservation principle. Here you just remember mg r cos theta is initial total energy, okay, which was only potential energy. There was no kinetic energy because it was released at that point. Now see see here. Therefore, 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 kinetic energy at point Y is equal to half m v square. V square is Rg sine phi. Now, using energy conservation principle. Okay, using energy conservation principle. Energy conservation principle, ECP, energy conservation principle. Initial total energy is equal to final total energy. So initial total energy, if you see, it was it was it was only potential mgr cos theta. So mgr cos theta, that is mgr cos theta is equal to uh, you see potential energy for y, that is mgr sin phi, mgr sin phi plus kinetic energy at y. Kinetic energy at y is half mgr mgr sin phi, half mgr sin phi, half mgr sin phi. So what you will get, mgr you can cancel, so you will get cos theta is equal to sin phi plus half sin phi, that will be 3 by 2 sin phi. So this will be your answer. Now let us match with the option. See, in option you can see, okay, 3 by 2. So only option third it seems matching. Now let us see option third. Let's say left hand side it is sin phi. So let us keep sin phi at left hand side. So what you will get? This implies sin phi is equal to 2 by 3 cos theta. So if you check with the option 2 by 3 cos theta, so your option 3 it is the correct option. Okay, this option is correct because we have obtained how much value, 2 by 3 cos theta. So this is your right answer. Okay, so this is how you need to solve this type of problem. If you solve, you will obtain the given marks. Okay, thank you.